Hello, this is Mr. Sarisa, and I'm trying to go over the example in 14.4 for instantaneous speed of a ball. And so you can follow along in the book if you want. I have a little picture over here that I'm not sure that you can read, but to help remind you of what's going on. I just wanted to get through this one just because I promised that I would try to get to it. And so in this example, they have they have um, the ball being thrown off of a roof, and the roof is 96 feet high. They give you the equation, and so I'm going to take that equation, that s of x equaling negative 16t squared plus 80t plus 96. And so that's nice, and we can certainly use that because the first question asks when it hits the ground, and this is stuff that you should already know how to do. But what I'm going to do with this is I'm going to factor out that negative 16, so I get the t squared plus 5t, minus 5t minus 6. And so that's nice, but I'm going to factor it a little bit further and have negative 16 of t minus 6 and t minus 1. So when we solve for the 0, then we can see right away, well, 16 can't equal 0. T minus 6, oops, that's a plus 1. That t minus 6 means that t will equal 6 to make it equal 0. And the t plus 1 means that mathematically it comes out to a negative 1, but in reality we can't go back in time to do that. So so there we have is that it's after, A would be after 6 seconds. And then for B, it's asking what time the ball will pass the roof on the way down. And so this, instead of plugging in 0 for the height, we're plugging in 96 for the height. And then I'm going back to the original equation here because the 96's will cancel out, and I'm left with 0 equaling negative 16. T, and I now factor, and so I get t minus 5. Then t equals 0, but they say on the way down, so that doesn't really count. We'll just use the t equals 5, so after 5 seconds would be the answer for that one. Alright. C, what is the average speed of the ball from 0 to 2 seconds? And so this is where we start using the math we learned in this section, where we have to have the s sub 2 minus s sub 0 all over 2 minus 0. And so it's just a matter of plugging in the numbers. And so if I plug in 2, I get 192. If I plug in 0, I get 96. All over 2 minus 0, which is 2. I do my subtraction, and then I do my division. And then so that's in feet per second. Right? Because the height's in feet, and then the t time is in seconds. And so there we go with that one. And then D, now we're looking for instantaneous speed of the ball. So this one's a lot trickier. We're finding the limit as t approaches t sub 0, which is the instantaneous part. And then so I'm going to take all these t's, and just rewrite it. But this time we subtract out the t sub 0's. So negative 16 t sub 0 squared plus 80 t sub 0. And we still have, the 96 that's there. And that's all over the t minus t sub 0. Alright, so we need to start simplifying things. And so one thing I'm going to do is distribute that negative, and I'm going to group like terms together. So negative 16t squared t squared, and then plus the 16 t sub 0 squared. and then the 80 T's, and then the 96's, which that's convenient, they just cancel right out. And I still have the T sub 0 there. So what I do now, I'm going to factor out these like factors. And so I just have the T squared minus the T sub 0 squared. And the 80 I'll factor out. I'll have the T minus T sub 0. And then in the denominator, I have T minus T sub 0. So it looks like we'll be able to factor out like terms. And here's a difference of squares. So I'm going to just simplify that. So these T minus T sub 0's all cancel. And I know that's really messy right now. So let's try to neaten that up. And we got negative 16. Negative 16 times T plus T sub 0. That's 80. And so, remember, we're actually taking all of this, the limit as t is approaching t sub 0. And so, I didn't write that for all of these, but essentially that's what I'm doing. And that will simplify to the negative 16 t sub 0 plus t sub 0 plus 80. So there's really two t sub 0's, right? So that's really negative 32 t sub 0 plus 80. Alright, so I know this doesn't look exactly like it does in the book, but it's the same equation. So we can still use that. And if we want the s prime, because remember this is the derivative, oops. Alright, that'll be the negative 32t plus 80. And now the rest of the questions pretty much all rely on this equation. And so I'm going to head up here and just work in this space, I think, for the remainder. And so D, we're on E now. And E is asking for basically S prime of 2. So I'm just going to plug in 2 for T. And then when I do that, I work it down, and that gives me 16 feet per second. And then F asks me, well, when is this going to equal 0? When's the instantaneous velocity going to equal 0? And that will be just setting the negative 32t plus 80 equal to 0. You end up with t equaling 2.5 seconds. And then G is asking when, or what's the instantaneous speed as it passes the rooftop on the way down. So we already established that it takes 5 seconds to do that. So I'm just going to plug in 5 in for t, for the instantaneous rate. And we end up with a negative 80. So what does that mean, negative 80 feet per second? Well, what that actually means, it's going in the downward direction. So it's going down 80 feet per second. Alright, so and then finally the last one instantaneous speed just before it hits the ground. So that's negative 32 times 6, because we already said it took 6 seconds to hit the ground. And again, we'll end up with a negative number, so negative 112 feet per second. Oops, negative 112 feet per second. Again, obviously the ball's about to hit the ground, so it's going down. And there you go. So, I hope that this helped, and good luck on your test.